Hi everybody. In this video, we're going to go over the 8.2 classwork. So classwork is here, and then there's an assignment, and then there is more problems down here for classwork, and then another part of the assignment. So split into two parts. So first, let's talk about the first part, electric current. I'll go off in a little bit. Again, describe the motion of charges from one terminal of a battery to the other through a flashlight. So if I were to draw a flashlight here, I would have a box, battery would go in there, and here's my light bulb. It probably can be screwed in, and there's a little notch at the bottom. Here's my battery. It's positive at the top, negative at the bottom. So the battery would lead to the light bulb. It would connect to the side or to the bottom, and then it would come out of the opposite one. And I know I'm going outside the flashlight here, but then it would eventually connect to the bottom. Usually there's a metal strip right here, and that metal strip is touching the bottom of our wire, of our battery. So the flow of electrons is going to go this way. So electron flow is going to go out of the negative, around, and then come back down into the positive. That's the flow of electrons. The flow of positive charges or conventional current is going to go this way. We're going to symbolize that with a capital I. That's what you always calculate in the formula for current. So it's going to go through our light bulb and then out this way, back into the negative terminal. So that's how charges flow in a battery. Light bulb, flashlight combo. What are some ways that electricity is created in the national grid? Turning of a magnet is the big one. You would have a dam. That dam holding back the water will make the water turn a big wheel, turning a magnet. If you have coal and you burn it, that steam that results from it, from heating the water, will turn a big fan, which turns a magnet. Anything that can turn a magnet, wind, turning the blades turns a magnet. That is how we're going to create electric current. You can also do it with solar panels. That has a photon of light. It's bumping off the electron, and the electron's going into the national grid. So it's kind of taking the place of that. And number 3, identify which of the following could produce a current. A wire connected across a battery's terminal. That short circuits the battery, but it does create a current. And that is our one correct answer here. Electrodes in a solution. You would need electrodes connected to something like a body, and then they could travel through. Salt crystals, whose ions can't move. Right there is the key. Cannot move, meaning charges won't move. You will learn what ions are, but ions relate to electrons. And a sugar water mixture has no talk about anything moving. So nothing happening there. Predict which way the positive charge will move between two positions of different electrical potential energy. Don't worry about it. But it should go from high to low. A waterfall, remember, goes from up high down to low. And now we're going to get into some calculation problems. So with that, let's go back to our notes briefly and look up some formula that we're going to use. The main one we're going to use is this one, where we are finding current from voltage over resistance, and we can rearrange that a bunch of different ways. So I equals V over R, and then we're going to be looking at these power equations, which are all on our reference sheet. So we'll reference this a couple times as we do these problems. So the first one is the current with a resistor has a current of 6.2. The voltage across the resistor is 110. What's the resistance of the resistor? Well, looking at our notes, going up to the first one, we know that current equals V over R. So setting that up, current equals V over R. Current was given to us as 6.2. The V was 110. The R is unknown. So I'm going to flip both of these around. So it's 110 divided by 6.2, and that equals my resistance. That answer will be in ohms. And that answer is 17.7 ohms. Number 6, the voltage across a flashlight bulb is 3 volts. So 3. And it has a resistance of 6 ohms. 6. What's the current? That's going to be equal to I, based on this formula right here. So 0.5 amps. Find the resistance of a portable lantern. It uses 24 volts, so 24, and draws a current of 0.8. So I need to find R. So I have 0.8. So I'll do the old switcheroo here, and resistance equals 24 over 0.8, and that's going to equal 30 ohms. Number 8, the current in a video game is 0.5 amps. If the resistance of the game's circuitry is 12 ohms, what is the voltage of the battery? 0.5 is my current. I'm looking for the voltage, and I know my resistance. So I will multiply 12 by 0.5. And that will equal my voltage. And voltage is going to equal 6 volts. Box some of these answers here. What's the difference between the current from a battery and the current from a socket? Well, a battery is going to be DC. It's going to be direct current, going one way, coming back around, one direction. And from an outlet or a socket is AC. It is alternating current. So if it's 120 volts in that outlet, it's going to move back 120 times, that electron. It's going to move back and forth between the same position 120 times every second. That's how fast it's moving. And what does an ammeter measure? Ammeters measure amps, which is current. So your homework would be working on these problems right here and down here. The second part is circuits. Describe the advantage of using a parallel arrangement of decorative lights rather than a series. Well, when things go out in parallel, the other stuff still works because there's still a pathway. So when one part of the light bulbs, the light set goes out, the other part still works. If it was in series, one missing light bulb or one burnt out light bulb would ruin everything. So we don't want it in series because that would ruin all the lights, not just a section of them. Contrast how a fuse and circuit breaker work to prevent overloading circuits. A fuse is a little device with a filament inside, and when the current coming through gets too hot or too strong, that current gets too hot and it burns up and breaks. So it's no longer able to let anything through. It's a gap. A circuit breaker deals with a magnet, and the switch is going to flip as soon as the current is too strong because it has this magnetic field. And with more current, the magnetic field is going to get bigger, and eventually it's going to trip the magnet that is by the switch, and then it's going to flip it up into a new position further away from the magnetic field, and that ruined the connection in the circuit. So ruins the connection in the circuit, and then you have a gap. You flip the switch down again, and then it will connect it. However, if it's too strong still, it would flip right back up again. So you need to unplug things to get it to work. Predict whether a fuse will work successfully if it is connected in parallel with the device it is supposed to protect. Well, if something's in parallel, it's going to go through both pathways. A fuse would be something that needs to be in series, though, because if it's in parallel, if our batteries over there coming through, and here's our fuse, and here's our device coming back around. If that burns up, everything's going to still go through the device. So if it's connected in parallel, it's not going to do its job. Will it work successfully? No, it will not. There'll be a lot of current really fast and burn that up, and then the pathway is going to go through the device, but there's nothing to prevent it from overheating anymore. 23, An electric space heater draws 29 amps of current when plugged into a 120 volt outlet. What is the power rating? Ooh, so we need some watts for this. So let's look at our other formulas for this. So we have three: power dealing with current and voltage, power dealing with current and resistance, and power dealing with resistance and voltage. We were given current and voltage, current and voltage. So we are going to multiply those together. So 29 amps times 120 volts. That results in 3,480 watts of power, and it would probably be reported in kilowatts, 3.48 kilowatts of power required. The current in a heating element of an iron is 5 amps. If the iron dissipates 590 watts of power, what is the voltage? Well, power is equal to current times voltage. So that means 590 is equal to 5 times our voltage. To find voltage, we'll divide 590 by 5, which is 118 volts. Makes sense coming from a 120 volt outlet. When a VCR is connected across a 120 volt outlet, the VCR has a current of 0.33 amps. What is the power rating? Power is voltage times current. So I would have to do 120 times 0.33, which is a third of that. 1/3 of 12 is 4, so this would be 40 watts of power. A 40-watt light bulb, same wattage as the VCR, and a 75-watt light bulb are in parallel across a 120-volt outlet. Which bulb has the greater current in it? So they're in parallel, so they can have different current. So let's do the 75 watt. That would be 75 watts of power equal to my current times my voltage. So the first current would be 75 divided by 120, which is 0.625 amps. The second one would be 40. Sorry, I guess that's the first one, divided by 120. And that's going to be 1/3 or 0.33 amps. So more power is going to require more current. So the current going through, the water going through is going to go through faster for the higher power light bulb, and therefore it's going to be brighter if you have more electrons flowing. So if you go to the store and buy a light bulb and you want it to be brighter, pick the wattage that's higher because that's the current. It's going to draw a higher current from the same outlet. 27, convert the following pictorials to schematic circuit diagrams and write a brief description. My brief description would be light bulb in series with a battery. My diagram would look like this. Done. This one would be 2 batteries in parallel with 3 light bulbs. So 1, 2. I draw 2 batteries like that. And then I need 3 parallels. Light bulb, light bulb, light bulb, and bring them all back home. There we go. Convert the following descriptions to a schematic circuit diagram. So draw some circuits. Draw a circuit containing a battery with 2 bulbs in parallel and 1 pathway with a closed switch and the bulb, and the other one with just the bulb and a resistor. So battery, parallel, I need a switch that's closed. So normally I would draw it like that, but I'm going to draw it closed. I need a bulb, it needs to go back home. The other pathway needs a resistor, which is a squiggle line. Bulb, back home. That's A. It says show the electron flow. Electron flow goes out of the negative terminal. It will go up here and back around. It will also go like that. That's the electron flow. Remember, conventional current comes out of the positive terminal. B, draw a schematic of the circuit with two dry cell batteries in series. So that just means 1, 2, and 2 light bulbs in which you could turn either off and have a complete circuit. Hint, you need 2 switches. So that means I need parallel. So here's my one switch with a light bulb back home. Here's my other switch with a light bulb back home. So turn this one on, it will flow. The other one won't. Turn this one on, it will flow. The other one won't. Turn both of them on, they both will flow. And C, draw a circuit containing a battery with 4 light bulbs in series, and then 3 pathways with a bulb on each path. So 4 light bulbs in series, 1, 2, 3, 4, and then 3 pathways, pathway 1, 2, 3. And then a bulb on each, bulb, bulb, bulb. Add switches to control each of the bulbs, and a 4th switch to control all 7. So I would need a switch right here for this one, and here, and here. And bring all those back home. And I need another switch to control all 7, which I could put anywhere here or down here. I'm going to put it right here. Right now it's in the on position, but there's my switch. There's no way to have these 4 light bulbs to turn off individually because it says in series. So I cannot have them go off, but I can have all of them go off. I can have just this one, just that one, just that one. But I actually need another pathway right here. I need a pathway so that I could have just those 4 light bulbs on and these off. So now I can have these on and any combo of those. It's unclear if I should have a pathway where these 3 light bulbs are independent. If that's the case, I would need a switch right here so I can turn on just these, and then I would need a pathway from here connecting to these guys over here. So then I could have the pathway be open here, so none of these on. It would then flow here, have the choice of going that way if it was closed, that way, or that way if it was closed. And then this one right here, if that one was open, it doesn't matter if that one was closed and all of these were closed, it would turn off all 7. So this is a little unclear, but there's a couple of ways that you could interpret this and satisfy the question. But this is very comprehensive answer. So hopefully you know how to use current, voltage, resistance, and power and to draw some circuits.